Show that 1 over a plus bx is equivalent to 1 over a minus bx over a squared plus b squared x squared divided by a cubed minus b cubed x cubed divided by a raised to power 4 plus dot dot dot. Now, if you see any kind of expression like this 1 over something, so to be that number, that expression raised to the power of minus 1. So we are going to use binomial theorem, binomial expansion theorem, when the exponent is not positive. So if you have something like that, a plus b x raised to power n, then we are going to have a raised to power n, then b raised to power 0. But here you know that it is bx. So bx raised to power 0, then plus n, a raised to power n minus 1, then bx raised to power 1 plus n into bracket n minus 1 over 2 factorial, then a raised to power n minus 2, bx raised to power 2 plus n into bracket n minus 1 multiplied by n minus 2 over 3 factorial, then a raised to power n minus 3, then b raised to power 3 plus dot dot dot. So it continues. It means that where n is equal to minus 1. So wherever we see n, we're going to put minus 1 there. So a plus b x raised to the power of minus 1 will now be equal to a raised to power minus 1. And any number raised to power 0 is 1. So you leave that one. Then wherever we see n, we're going to put minus 1. So minus 1 minus plus times minus. The friend of my enemy will be my enemy. So minus 1, then multiply by a raised to power minus 1 minus 1 minus 1, then minus 1, then multiply by bx plus minus 1 into bracket minus 1 minus 1 over 2 factorial. 2 factorial means 2 times 1. Then a multiplied by minus 1 minus 2, then b squared x squared. Then plus minus 1 into bracket minus 1 multiplied by minus 1 minus 2 over 3 factorial. And 3 factorial is equal to 3 times 2 times 1. So it has 2 factorial is 2 times 1. So then a raised to power minus 1 minus 3 bx raised to power 3. So we have b cubed x cubed plus it continues. So we have a plus b x raised to power minus 1. So this one will give us 1 over a, then minus a raised to power minus 2. Minus 1 will give us minus 2. Then bx. So and this a raised to power minus 2 will give us 1 over 2 squared. So multiply by bx will give us bx over a squared. Then minus 1 will give us minus 2. Minus 1 multiplied by minus 2 will give us plus 2. So we have plus 2 over 2. Then a raised to power minus 1 minus 2 minus 3 to power minus 3. Then b squared x squared. And recall that this 2 will cancel 2, so we are left with 1. And a raised to power negative 3 will give us 1 over 3. 1 over a raised to power 3. Then we multiply this one by b squared x squared. So we have b squared x squared. And let's cancel this one because of time. So then This is a minus 2, minus 1 minus 1 minus 2. This is a minus 1 minus 2, that is minus 3. So minus 2 multiplied by minus 3 will give us minus 6. Minus 2 multiplied by minus 3 will give us 6. So 6 multiplied by minus 1 will give us minus 6. So we have minus 6 then divided by the 6 in the denominator. So we have a raised power minus 4, then b cubed x cubed plus dot dot dot. So this 6 will cancel 6, so let's cancel that one out. Then a raised power minus 4 will give us 1 over a cubed, then multiply by b cubed x cubed. So b cubed x cubed, then plus dot dot dot. Let's check if we have the same thing. So now let's rewrite this one as fraction. So we have a over 1 over a plus bx is equal to 1 over a minus bx over a squared plus b squared x squared over a cubed, then minus b cubed x cubed over a raised power 4 plus dot dot dot. So that means we have shown it. So it is equivalent. It is equivalent to it. It is equivalent to it. So if you see the question given to us and the one that we showed, you can see that they are the same thing. That means we have proven it. So till I see the next class, make sure you go through everything. If you have any problem with it, let me know. Bye bye.